Okay, hello everyone. This is Mr. Cunningham doing the Algebra 1 review, but if you're watching that, you already know it. I'm just making sure I'm recording and that I'm sharing the screen. Let me double check, make sure I am sharing the screen. I better be. Let's see. You are screen sharing, it says, and am I recording? I am. Okay, sorry for the delay, everyone. All right, here we go. Remember, try these problems first, then check with the video. If you're checking this right now without having tried it on your own, you are shortchanging yourself. You got to practice and check and practice again. Okay, do a little pre-work first. Add these columns up. They should all add up to, or sorry, these are rows, adding up to 50. That work is going to help me as I have denominators ready for my percentages and numbers later. And they ask, like, how many adults are fans of the New York Yankees? Go to that column where there's both New York fans and adults. You have three. How many people are Detroit Tigers fans and children? So Tigers fans and children is in this column right here. Not much work yet. Now we have some percent of teams are fans of the New York Yankees. So we got to think, okay, this only asks about teens. There are 50 teens. There's my denominator. And then we have four, right here. 4 out of 50 would give me 0.08, which is not 80%. It is 8%. Okay? That's like having 8 out of 100 as opposed to 80 out of 100. So make sure you know the difference between 8% and 80%. All right, onward. I might have to flip back to that. Well, I can just easily fill these out again. So I don't have to flip back and forth. That would be kind of inconvenient. Okay, percentage of everyone surveyed who are uh, Mets fans. So everyone surveyed is an important word there. That means I know I'm going out of 150. And Mets fans, there were 90. That gives me 0.6. Now that's not 6%. That's 60%. All right, what percent of Detroit Tigers fans? So my denominator here is now 51. And you need to show this work on your test to get credit. You've got to show what you're dividing by and what you're dividing into. So 12 out of 51 because we have adults there, 12 out of the 51, 0.235, which rounds up to 24%. What is the percentage of everyone surveyed who are Yankee fans? We only have 9 out of that 150. Okay, so 0.06, that is 60. I just said earlier that's not 60. That is 6%. What I meant to say, know the difference between that and 60% because Mets fans was 60%. You can see there's much fewer. This is the difference between 60% and 6%. All right, hopefully my mistake didn't screw you up. Let's move onward. Okay, so lines of best fit. Lines of best fit should kind of you should try and split your dots down the middle, right? So if you draw that line and most of the dots, I'm covering a lot of the dots there with the line, and there's like an equal amount above and below. Maybe mine should have been a little lower here. But the two things it's asking here is it on your paper anyway? It asks, is it positive or negative? And is it moderate, weak? or strong. Okay, if the dots are really close to the line, if you can draw a line that it's really close, then that means it's a strong relationship. Positive or negative, it just means like, hey, are you going, which direction is this line going? It's going up, therefore it's positive. Strong, I would say. So it doesn't ask this on here, but you're looking for an R value, close to one, something like zero point 0.8, zero point 0.9. That's the sort of thing we're looking for here. Here, I don't even know which direction I would draw a line of best fit here. I mean, maybe like this for positive. You could even argue that it's negative, but I'll just go with positive here. If you did negative, probably that works too. I wrote that it's positive. This line isn't really predicting what's happening. The dots are everywhere. So this is a weak relationship. This would have an R value really close to zero, something like zero point 0.1, zero point 0.05, zero point 0.2, something like that. Okay. Now, when you look at this last one, kind of weird. I don't know, I can't tell. I think that my camera stays somewhere, but my view keeps blocking my view of the screen. So hopefully it's not bugging you guys. Maybe it's just bugging me. So if I drew a negative, first of all, that is negative, right? So what type of relationship? It's negative. Okay. And it's pretty good. Like most of the dots are close, but like, you've got them, it predicts the direction, but maybe they're not that close. We would say that's a moderate relationship. Like it's close, but it's not going to be totally predictive, not like a strong relationship in the first one. So we'd be looking for R values, somewhere in like the zero point 0.7 range, maybe 0.65, something like that. Oh, sorry, it should be negative zero point 0.7 or negative 0.65 because it's going down. Okay, so speaking of this, like this is an inexact science, right? These R values. You'll learn the exact science when you do like uh, AP stats and that sort of thing. But really, we're just looking for like, can we kind of estimate what's going on here? So I'm drawing these lines just to give myself an idea of what I can expect here. I'm going to look at D and B first, and then I'm going to leave C to last because it's, I don't know, maybe something like this. Okay, D and B. I look at D and B and I say, okay, they're both positive. So which ones could they be? They're either number two or number four, because those are my two positive options. And then I would say to myself, okay, well, which one of these is the line more predictive? The higher value is going to be the one that's more predictive. And I would say scatter plot B, that you have more numbers, dots, I should say, more dots close to the line. So that's why I would go with number four here. And just process of elimination. Well, D is positive. The only other positive option I have is 0.65. So that's why I went with number two. And looking at this, here's another moderate relationship. It's negative. The only two options I have for scatter plot A, scatter plot C, scatter plot C, it could be positive, it could be negative. It's really just going to be really close to zero. So what's the number that's the furthest away from one in all of these? So that's number one, which leaves number three, negative 0.72. And that makes sense for that scatter plot because it's a moderate relationship. It's a negative line. So that's why we go with number three here. That's, you got to do some process of elimination there. Okay, so moving on, let's look at the situation we have here. So we're looking at uh, potato chips being judged. They're what is the line of best fit that matches here? Okay, so basically, what are we saying here? They're saying, okay, the cost of potato chips and what is the rating that people like. Like, okay, I bought a $2 bag of potato chips. Well, if you took a $2 bag of potato chips, the line predicts that the rating would be, somewhere between 5 and 7. That's the range that we're in. So that's Um, that's kind of the study that is describing here. Now, what do I notice when I see that this is a positive line? Okay. And I see that my y-intercept, I can't even see my y-intercept, which tells me that my y-intercept is going to be somewhere in the negative range. Is there every line here? Let's look at number one. Number one has a positive slope, negative y-intercept. Okay, so that's a candidate for my answer. The second one has a negative slope. Get rid of it. Second one, it has a positive slope. However, the y-intercept is also positive, which means it can't be the answer. So there's really only one option. Okay, what does the slope mean in the context? So if you're ever wondering what the slope means and you're totally stumped, just literally go to the y-axis. Change in y over change in x. That's your slope. What does the slope mean? It means that your rating, right? It says rating on the y-axis goes up as price of chips. That's what's on the x-axis. Gotta move the picture again. As price of chips goes up. Okay, now that would be an okay answer. A good answer is the rating goes up by, we're talking about our slope. We're going up by 5, right? We had a m equals 5, right? So of the chips, the rating of the chips goes up for every dollar spent. So the rating goes up 5 points as price of chips goes up every dollar, right? So the more money you spend on the chips, at least according to the study, the higher rated they'll be. So like a $1 bag of chip, it has a pretty low rating, whereas a $2 bag of chips, it goes up close to 5 and 6. What does the y-intercept represent in this? Y-intercept, so that would be a 0 for price. And what was the y-intercept from here? -5. So 0 for price, -5 rating. So that means that free chips score negative on this scale. Now, does that necessarily make sense? Well, I don't know. Does it have a 1 to 5 rating or a -10 to +10? So, but what it's essentially saying is that free chips aren't as good. Maybe that's why they're free, right? So, or really cheap chips, like a 10-cent bag of chips is going to get lower ratings. That's essentially what we're saying here, that really cheap chips aren't going to be that good on the scale. Best option for correlation coefficient. So this is I'm going to get rid of any negative option. First of all, that line is going up. So I'm getting rid of the -1. I'm getting rid of -0.6, getting rid of 0. Okay, is this line perfect? Because that's what a 1 would be, a rating of 1. It's a pretty predictive line. So, but it's not perfect. So I'm going to get rid of 1 because it's not perfect. Now, I think zero point 0.6 and zero point 0.9 are both pretty good answers here. I would actually love to see like a 0.84 or 0.85, something like that. But I really think it's probably closer to zero point 0.9. It'll be more clear on the test. That's my little hint, my little Christmas present for you, that it'll be a little more obvious because in between these two, I would love to see an answer of like zero point 0.8 or something, right? So if you went with either zero point 0.6 or zero point 0.9, not mad at you. Personally, I leaned toward zero point 0.9. All right, right here in this study, again, it's asking about what is the y-intercept. If you're wondering what the y-intercept is, literally go to the y-axis. What does it say? Average rent in dollars. Okay, so that's years after 2000 is on the x. So if you're 0 years after 2000, That means it is the year 2000. And 800, that's your rent. Okay. So it means that in the year 2000, that would be 0 years after 2000, average, ooh, sorry about that spelling there. Average rent in New York was $800. This makes sense. This is when they started the study, right? And as the years went up, the average rent went up. All right, so right here, more along the same lines of renting, and as years go by, or really in this case, as the your average income goes up. Okay, what does the slope mean in this situation? Again, what are we measuring on the y-axis? We're measuring, and what are we measuring on the x-axis? In this case, we're measuring rent as it relates to income. So how much are people spending on rent as their income goes up? So if you just said it's how much your rent goes up compared to the income, you would at least have an okay partial answer, right? But let's be specific here. We have 0.031. What does that mean? That means that for $0.031 of rent goes up for every $1 in income that goes up. And that, I mean, even that, like, even though mathematically that makes sense, that's probably not how people would describe it, right? You might say that, okay, that for it's 31 cents spent on rent for every extra dollar earned. You don't multiply these out by 100, and you'd say uh for every $100 more you're making, you'll spend $3 more in rent, or for every $1,000, every $1,000 in income, you'll go up. Rent raises approximately $31. Take that out again, and you say, okay, every 10,000 more in rent, you have another 300, or 10,000 in income, you have another 300 spent in rent. It's basically saying as income goes up, you spend more on rent, and then you can just multiply it out. But this essentially is saying 3 cents in rent for every $1 in income. Okay, onward. Okay, again, what are we looking at here? Describe the correlation between the age and accidents per 100. Estimate the correlation coefficient. Okay, so what exactly are we saying? We're saying that as up, age goes up, accidents goes down. Makes sense. Inexperienced drivers more likely to get in crashes, right? So, less experience you have, or flip it, less experience you have, more crashes you will are likely to get in, or more crashes involve inexperienced drivers, however you want to phrase that. What would I predict here in terms of an R value? It looks moderate, so I would say the R value is going to be negative. Or no, I'd say in the 0.7 range. Okay. I would say if you extended this graph out, you got to like, 60s and 70s, you'd probably see it go back up as people get a little older. All right. Last one. Last one, best one. Again, do your work ahead of time so that it's not so tough when you're uh, answering questions later. All right, right here, 81, 54. So 54 to 81, what would I did? 81 minus 54 gives me 27. Now that I have 27 here, I know that's going to add up to 44. Add these together, I have 120. Now I have all the numbers that I might need later, even though there's just one question about it. You know, I want to know that I have all my numbers in front of me. Identify the number of his schoolmates that have no car and have a laptop. No car, have a laptop. This question just asks the specific number of students. So that math that I did beforehand, 81 minus 54, show that work to get the answer of 27 schoolmates. Schoolmates says schoolmates. I don't think I've ever said that in my life. Okay. Um, good luck on the test. Study. Peace.